In this week's experiment, we will be determining the gas constant R and the molar volume of oxygen. The molar volume is the volume occupied by 1 mole of a substance, whether it be a chemical element or a chemical compound, at a given temperature and pressure. 1 mole of any ideal gas occupies 22.4 liters at standard temperature and pressure. You will compare the ideal molar volume with the molar volume of a real gas, oxygen, that you produce in this lab procedure. For the experiment, you will be given a potassium chlorate sample. When heated to a temperature between 380 and 400 degrees Celsius, all the potassium chlorate is decomposed to potassium chloride and oxygen gas. The reaction is shown on this screen. Notice that the stoichiometric ratio of potassium chlorate to potassium chloride is 1:1. Therefore, the difference in weight between the potassium chlorate and the resulting potassium chloride must all be due to the loss of oxygen. So by weighing the unknown before and then after heating, you will be able to determine the weight of oxygen produced. The objectives of this laboratory are to determine the value of the gas constant R, to determine the molar volume of oxygen collected at standard temperature and pressure, and learn the water displacement method for gas collection. For some safety precautions for the lab, avoid skin contact with all chemicals, and also be careful that the ring stand and its components will be hot. First, we'll need for our procedure to prepare our sample. On a piece of weighing paper, weigh out between 0.9 and 1.1 grams of the potassium chlorate and 0.3 grams of manganese 4 oxide. Record these weights accurately on your report sheet. Flush any excess potassium chlorate down the drain. Manganese 4 oxide can be placed in the trash can. Transfer both of these samples into a dry, taired, or weighed ignition tube. The tube may be stained from previous use. It is not necessary to remove these stains. Shake the tube to ensure that the chemicals are mixed well, and then weigh this entire ignition tube assembly, the ignition tube, the potassium chlorate, and the manganese 4 oxide. And now for our setup for our gas collection system will look like the one on this screen. Remember that the water level in bottle A should be just below the bottom of tube B. To fill tube C, place a disposable rubber mouthpiece over the tube that goes into the ignition tube. Remove the pinch clamp between bottle A and the 500 milliliter beaker and blow into the tube until water fills the entire length. Immediately replace the pinch clamp. Remove the mouthpiece. Carefully empty the 500 milliliter beaker. Remove the pinch clamp between the bottles, and if no water or very little water seeps into the beaker, our system is airtight. If water leaks into the beaker, then we'll have to repeat these steps. Remove the pinch clamp. Raise the beaker until the water level in A and the beaker are even. Close the pinch clamp, and this ensures that the ignition tube is equal to the atmospheric pressure, and then empty the beaker and place it on the lab bench. The instructor will demonstrate this procedure. Also, have your instructor inspect your apparatus prior to going ahead and heating the ignition tube. Once approved by the instructor, you can go ahead and start heating your ignition tube. At this point, make sure that the pinch clamp on tube C is open before you start heating the potassium chlorate mixture. Things to remember while you're heating your sample. Start by using a soft blue flame. Hold the burner to control the rate of heating. Heat it from top down to prevent escaping oxygen being blown out of the reaction mixture. Make sure you do not heat and burn the clamps on the apparatus or melt the rubber stopper. Control the rate of heating so that the molten reaction mixture does not rise above the bottom third of the tube. Also, look at the water flow coming out into the beaker. If it begins going fast, over a few drops per second, then you will need to remove some of the heat. When you note no further reaction occurring by observing the water level in the beaker, heat the tube for an additional 5 minutes and then allow it to cool to room temperature. You raise the beaker or the flask until the water level in A and the beaker are equal. Close the pinch clamp. This ensures that the pressure inside the ignition tube is equal to the atmospheric pressure. Your instructor will demonstrate this procedure. Measure the volume of water in a 500 milliliter beaker using a graduated cylinder. Take the temperature of the water in the beaker. This will be the temperature of the gas. After the ignition tube has cooled, reweigh it. By subtracting this weight from the initial weight of the tube and its contents, you can obtain the mass of oxygen collected. And now for our lab report. The numerical value of R is found from the values measured in lab for the partial pressure of oxygen, the volume, the number of moles of oxygen, and the temperature. The values are substituted into the ideal gas law equation, PV equals nRT, and the resulting expression is solved for R. From the mass of oxygen, you can divide this by the molecular mass, 32 grams per mole, and determine the moles of oxygen. The volume of oxygen gas that was evolved, which was equal to our water volume displaced, will be corrected to the dry volume at standard temperature pressure using Dalton's law, using Boyle's law, and Charles's law, which give us the combined gas law. To determine the pressure of oxygen, we need to take into account several factors. First, we will assume the total gas pressure in the collected bottle is equal to the atmospheric pressure. Second, we must take into account, since the oxygen is collected over water, the water vapor pressure will also contribute to the total pressure, according to Dalton's law of partial pressures. Therefore, the oxygen pressure is equal to the atmospheric pressure minus the pressure of water, which will be found in a table in your textbook.